We are going to take a closer look at how we control the execution of code. In other words, how to direct what code executes when. Control flow is the term we use to describe how we direct the execution of the code within a program. Most languages include a series of control flow structures or statements that allow you to control the flow. In other words, what code executes when. When it comes to code execution, there are three general methods that can be used: sequential, conditional, and iterative. Sequential refers to completing tasks in a well-defined order, one at a time. Conditional refers to selecting what tasks to perform when, or if at all, based upon one or more conditions. And iterative refers to performing tasks in a repetitive fashion. Let's take a closer look at each one. Sequential execution is when statements are executed unconditionally, in order, one by one, from top to bottom. Conditional execution is when statements are executed only if some condition holds true. Notice the yellow diamond in the flowchart. This represents a conditional test. If the test is true, one thing happens. If it fails, the code continues on in another separate direction. Iterative execution is when statements are repeatedly executed using what's known as a loop. A block of code is executed with each trip through the loop, referred to as an iteration. Notice that there is still a condition, but in this case, the condition is repeatedly tested. Once the condition is no longer true, the code continues on. Let's take a look at each execution type in context. In the first example, there are 5 blocks that are executed unconditionally in order, one by one, from top to bottom. In the second example, the happy icon is shown conditionally, only if the happy is equal true condition holds true. In the last example, a show number block is repeatedly executed a certain number of times using a loop. When we execute different code based upon various conditions, we are employing conditional logic. This normally involves using some variation of the if statement and one or more conditions, each evaluating to true or false. Similar to most traditional programming languages, the microbit supports the if statement as well as its many variants. When dealing with the if block, you perform a conditional check. If that check evaluates to true, then its containing blocks are executed. In certain cases, you may have to check more than one condition. This is when you add else-if clauses to perform additional conditional checks. It is important to remember that only the first condition that evaluates to true is executed. What happens if none of the conditions evaluate to true? In these cases, you can add a special else clause whose blocks will execute in the event that all explicit conditional checks fail. When we repeatedly execute code, we are employing iterative logic. Remember, to reiterate is to repeat oneself, hence the name iterative logic. This normally involves using a for or while loop, which controls how many iterations or times we travel through a loop and the code it contains. Similar to most traditional programming languages, the microbit supports the for and while constructs, plus a special one called repeat. The for block executes a loop by traversing some sort of sequence, like iterating once for every item in a list. The while loop is used to iterate provided some condition remains true. And a repeat block simply iterates a set number of times through a loop. Here's a quick look at some of the control flow blocks you can explore as you continue your microbit adventure. Of course, a huge part of using these control flow structures is to define their conditions. Defining a condition in code can be thought of as asking a question that, when answered, returns true or false. When we ask questions in code, we normally use some kind of operator. For example, a relational or comparison operator can be used, as in this example, to define a condition which dictates the flow of the program. In this example, the greater than or equals to relational operator is used to define the conditions that compare the age variable to different values, like 21 and 18. In programming, you can normally use the same relational operators you already know with some notable additions, like checks for equality and inequality. Again, Such operators are really helpful when writing the conditions needed by control flow structures and the like. Here's a quick look at some of the relational operator blocks you can explore as you continue your microbit adventure. Let's talk about another special family of operators called logical operators. Logical operators, often called boolean operators, are yet another tool in your programmer toolbox that can help you write conditions. Logical operators allow you to perform basic logical checks. In this example, the AND logical operator is used to refine our condition. In this example, not only must the age variable be equal or greater than the value 21, but the person entering the club must also be a VIP member. Both parts of the condition must be true. That is why it is called the AND operator. It requires that more than one thing be true. In programming, you can normally use one or more logical operators to implement logic checks. And, or, plus not are the most common so-called boolean operators you will be using to build your conditions, and much, much more. Here's a quick look at some of the logical operator blocks you can explore as you continue your microbit adventure.